Okay, Spongebob number 17, we're going to be multiplying binomials. And when we multiply binomials, we use a order called FOIL, which is first, then we multiply the outside, then we multiply the inside, then we multiply the last terms. Okay, step one, with these, we will preserve the integrity of the original problem by writing it the second time. So 3x plus 5 and x plus 4. I'm going to add a 1 to the x here. And the FOIL process is to multiply this first term with this first term. So I use the letter F, first terms. That's my F in FOIL. So a 3x times a 1x gives me 3x to the second power. Then I'm going to multiply my outside terms. The 3x and the 4 are the outside terms. So when I multiply the outside terms, I can get 3x times 4, which would be 12x. Okay. Next, we'll multiply the inside terms here. The inside terms would be the 5 and the 1x. Multiplying 5 times 1x will give us 5x. So plus 5x, positive 5x. Our last term, we multiply the last terms, which are the 5 and the 4. These are the last terms. 5 times 4 is 20. 20 here. Next, once we have all the multiplications out the way, which is the FOIL, we're going to then collect like terms. And we have a 12x and a 5x to collect. 3x squared, don't need to collect that. But the 12x and 5x, same sign to add, bigger sign wins. So that's 17x plus 20. That's done. Okay. Next, number 2. Again, we're going to repeat the process, repeat the problem, preserve the integrity of the original problem. And we're going to multiply the first terms here, the 5x and the x, to get a 5x to the second power. We're going to multiply the outside terms here, which are the negative 5x, sorry, the positive 5x and negative 2. And that gives me negative 10x. Multiplying the inside terms, the 3 times the x gives me positive 3x. And then multiplying the last terms, the 3 and the negative 2, that multiplies and gives me a negative 6. Positive times negative is negative, so negative 6. Okay. There are no x squared terms to collect, so that remains 5x squared. The x terms, we can collect these two right here. Different sign, or bigger sign wins, and different signs subtract. So negative 7x minus 6. Here again, preserving the integrity of the original problem, we'll write down 3x minus 5 and x plus 4, and multiply the first terms together. The first terms of 3x and x, which make 3x to the second power. The outside terms are the 3x times 4. That makes positive 12x. The inside terms will be negative 5 times x. That'll give us negative 5x. And finally, our outside terms, our last term, should I say, will be negative 5 times 4, which is negative 20. Okay, now let's start collecting my terms. First, we'll start off with the x squared terms. The x terms are 12x and negative 5x. The bigger sign is positive, that's positive. And different signs subtract, so we'll get 7x, and then the minus 20 there. Next, let's repeat this and multiply the first terms, which are the 5x times the x, and that gives us 5x to the second power. That was the first terms. Then I'm going to multiply the outside terms, which is 5x and negative 2. That gives me negative 10x. Multiplying the middle terms, or the inside terms, will give me negative 3 times x, and that's negative 3x. Next, we're going to multiply the last terms, the negative 3 times the negative 2. That's going to give me a positive 6. Then collecting like terms, we have a 5x squared And the bigger sign here between the x's is negative, so it'll be negative. And these are the same signs, so they'll add up to 13x, and then plus 6. And let's see if we can see this last problem here. Okay, the last problem, or number 5, is x plus 3 times x plus 3. So the same binomials. Okay? So when I FOIL this, I'll get x times x, which we remember as x squared. X times 3, see that was the first term, this is the outside term, which will be 3x. It will multiply the inside terms, that will give us 3x. And then we'll multiply the last terms, which is 3 times 3, that'll give us 9. Okay. From there, we'll have x squared here. And we'll collect these terms, they're both positive, so this will add to 6x, and then plus 9. Okay, next. These two binomials are the same binomials. So we're basically squaring the binomial. So let's preserve the integrity of the original problem. And then we're going to multiply the outside terms, which is the 5x, sorry, the first terms, which is the 5x times 5x. So the first terms gives us 25x to the second power. Multiplying the outside terms will be 5x times negative 8. That's negative 40x. Multiplying our inside terms, we'll get negative 8 times 5x, and that's negative 40x. And then finally, negative 8 times negative 8, which are the last terms, that'll be positive 64. Okay. Next, the x squared terms, 25x squared. That doesn't collect with anything, so it just becomes 25x squared. But I do have a negative 40x and negative 40x. So the bigger sign wins, which is negative. And same signs will add, so we'll get 80x plus 64. That's done. Now, if you notice, these two binomials here only differ by positive and negative signs. All the other terms are the same. So when we have binomials that are the same, but one is an addition of a subtraction, we call these conjugates of each other. And when we multiply conjugates, binomials that are conjugates, watch what happens. Okay, let's preserve the integrity of the original problem. And we're going to multiply the first terms together, x times x, so we get x squared. We will multiply outside terms and get x times negative 2. Well, that's negative 2x. Multiplying the inside terms, which is 2 times x, that gives us positive 2x. And lastly, we're multiplying the positive 2 times the negative 2. That'll give us a negative 4. Okay. The x squared term does not collect with anything. But if you notice that the negative 2x and the positive 2x cancel each other out, and we're left with the minus 4. Okay. So when you multiply conjugates, you'll always have a binomial at the end as opposed to a trinomial when you multiply binomials. And I'm sure you noticed that when we were multiplying these binomials, the products end up being trinomials. With this special case, multiplying binomials and binomials here when they're conjugates will give you other binomials. So here we go. Once again, this is a binomial times a binomial, and they're both conjugates of each other. So let's multiply them and see what we get. So the first terms, 5x times 5x, gives us 25x to the second power. The outside terms gives us 5x times negative 3, and that's negative 15x. The inside terms gives us positive 15x. And multiplying the last terms, the positive 3 times the negative 3, gives us negative 9. Okay. So when we collect like terms, we'll get the 25x squared here, but the x's will cancel. I have a negative 15x, positive 15x, that cancels, and we're left with just a negative 9. So we multiply binomials and actually got a binomial. Now, this particular binomial actually has a name to it. It's called the difference of two squares. We'll talk about that a little deeper later on. Okay, once again, we have conjugates here multiplying. So let's preserve the integrity of the original problem. And I'm going to multiply the first terms here. The x squared times the x. And we'll get x squared. Oh, sorry, x to the fourth. Okay. And then the outside terms, which is x squared times negative 9. Negative 9x squared. Then the inside terms, which is 9 times x squared, that becomes positive 9x squared. And then lastly, we'll multiply a positive 9 times the negative 9. That will be negative 81. Okay. So let's collect like terms. The x to the fourth doesn't have anybody to collect with. It's kind of lonely, just sitting out there. The x squares do collect. We have a negative 9x squared and a positive 9x squared. They collect and cancel. And we're left with the negative 81. Again, this would be the difference of two squares. Okay, number 5. And is that still on screen? Okay, it is. Okay, I'm going to repeat the problem to preserve the integrity of the original. And multiplying the first terms, which are the 2x squared times the 2x squared, we'll get 4x to the fourth power. That's our first term. We multiply our outside term, should I say, the 2x squared times negative 1, we get negative 2x squared. Then I multiply my inside term, and I get 1 times 2x squared, and that's positive 2x squared. And lastly, I multiply my 1 times negative 1. That gives me negative 1. Okay. Collecting like terms, we'll get 4x to the fourth power. The x squares will cancel, negative 2x, positive 2x, and we're left with the negative 1. Which again, this is a binomial called the difference of two squares.